Today we're going to talk about Lesson 1-1, Evaluating Expressions. The order of operations is used to evaluate expressions with variables and expressions with numbers. You all should be familiar with please excuse my dear Aunt Sally. Or what a lot of people call is PEMDAS. And what that stands for is this is the order of operations on how you go about a problem. P stands for parentheses. E stands for exponents. The M and the D stands for multiplication and division. Now, the reason why they are on the same line is because you're going to do multiplication and division from left to right. And then we have our last two, which is addition and subtraction, which is also on the same line, and you do these from left to right as well. Now, also in parentheses, we do include brackets, and other grouping symbols that go along in there. But you do what's inside the parentheses first, and then you go about your exponents, your multiplication, division, addition, and subtraction. That's very important to know now because once we get into algebra, we're going to be doing things in the reverse order of them. Algebraic expressions, what do they look like? Adults are roughly twice as tall as they were when they were 3 years old. As shown in the photograph at the right, this suggests a simple rule of thumb for predicting the adult height of a 3-year-old child. Multiply his or her current height by 2. In the language of algebra, if C, that's my variable, represents the height of a 3-year-old child, then all you would have to do is take 2 times C, or what is actually 2C, for short, is the child's predicted height as an adult. So, say for instance, the child's height was 2 foot. Okay? 2 times 2 then would only be 4, so that child would only, predicted height would be 4 foot. The letter C is a variable. Very important to understand. A variable is a letter that could be any number. Some kid could be 2 foot tall, some kid could be 2.5 foot tall, some kid could be 3 foot tall at 3 years old. We don't know. It could be anything. 2C is what we call an algebraic expression. Okay? A variable, and you're going to want to write this down, is a letter or other symbol that can be replaced by any number or other object from a set. When numbers and variables are combined using the operations of arithmetic, the result is called an algebraic expression. So my algebraic expression is when numbers and variables are combined, operations of arithmetic. Some examples of algebraic expressions are 7y, 5x minus 9, see, letters, numbers, algebraic expressions. Side by sign is multiplication. Remember, that's an algebraic expression. There's multiplication in there using operations of arithmetic. And this whole thing is also a expression. Finding a numerical value of an expression is called evaluating the expression. So in order to evaluate an expression, you have to know the number of what you're putting in for your variable. And then you follow your order of operations. I'll show you this in the next slide. If you look at example 1, here's my algebraic expression. They are telling me what A is. A is 5. So in this case, for A, wherever I see an A, I'm going to put in the number 5. So this becomes 3 times 5 squared. Now remember my order of operations. Okay? Do I have parentheses? I do have parentheses, but there's nothing to do in those parentheses. There's just the number 5. I can't add, I can't subtract, I can't multiply, I can't divide. So I got to go to the next thing, which is exponents. Do I have an exponent? Yes, there's an exponent on this 5. Well, what is 5 squared? Everybody should be telling me that it is 25. Then I do my multiplication and division from left to right. Do I have multiplication? Yes. Side by side means multiplication. There's an imaginary multiplication symbol right here. What's 3 times 25? Well, I get 75. I know I'm done because there's no other operations that I can do. So let's look at B. Kind of the same process, but a different number. Or a different problem. This is the expression. I'm still putting 5 in for A. So, parentheses, 3 times A. What's my A? My A is 5. Then they want us to square that. So we have to do what's in parentheses first. What's in parentheses? Well, 3 times 5. What is 3 times 5? 3 times 5 is 15. Then they want us to square 15. 15 squared is 225. Notice how what looks to be the same expression really isn't, due to the fact of where you put your parentheses at or your exponent. Some properties that you need to know that you all need to write down. Algebraic definition of subtraction. This says for all real numbers, that means any number you could put in for A and B, A minus B equals the same thing as A plus a negative B. So what they are saying is 3 minus 2 is the exact same thing as 3 plus a negative 2. Okay? Let's do this. What's 3 minus 2? Well, 3 minus 2 is 1. 3 plus a negative 2. If you remember your rules from elementary and junior high, if we're adding integers, and the signs are opposite, which they are here, I get a positive 3, I get a negative 2, you go ahead and subtract those two numbers. Well, when I subtract those two numbers, 3 minus 2, it is 1, and I use the sign of the bigger. Well, 3 is bigger than 2, so I'm going to use the positive sign. Notice these two things, however written differently, are the same thing. Down here, algebraic definition of division. For all real numbers A and B, that simply just means A and B can be any number. With B cannot equal 0. B cannot be 0 because we cannot divide by 0. What they're saying is A divided by B equals the same thing as A times 1 over B. So let's try this. 3 divided by 4 is supposed to equal 3 times 1 over 4. All I did was let A equal 3. I let B equal 4. Well, what does 3 divided by 4 come out to? Well, on your calculator, it would come out to 0.75, or how Mr. Johnson just writes it, is 3 divided by 4, which is also 0.75. This, and how we do our order of operations, we have to take 3 times 1 first, then divide it by 4. Well, what's 3 times 1? 3 times 1 is 3, and then I divide it by 4, is also 3/4, or what is 7.75. Moving along. It says, remember that there are several symbols for division. The operation A divided by B can also be written as A over B or A backslash B. In all cases, B, the denominator or the divisor, can never be 0. It is undefined, okay, when dividing by 0. So for an example, they have 5 divided by 12 is the same thing as saying 5 divided by 12 this way, which is saying the same thing as 5 divided by backslash 12, which is saying the same thing as 5 times 1 over 12. So on and so forth. Here's 2 other examples. I threw this in here. Write 3 different ways to say 5 backslash 6. Well, I can write it as 5 divided by 6. I can write it as 5 over 6. And I can also write it as 5 times 1 over 6. All these things say the same thing. Evaluating with technology. Scientific and graphing calculators use the algebraic order of operations. However, they can differ in the keys they use for squares, exponents, and square roots. Some possible key sequences are shown below. The order of entry is similar to the order you use to write the symbols by hand. When you're squaring something, what you're going to have to do is type in the number that you're going to square and press the squaring key. The squaring key is x to the second power. So you type in 5 x to the second power, hit equals, and you are going to get 25. Let me bring up my calculator for you. It's going to take a second here. I apologize for the inconvenience. Anyways, this is what your calculator is going to look like. Here is my square feature right here, x to the second power. So I would press 5 squared, hit enter, and we all know that 5 times 5 is 25. The next thing is our exponent key, because you don't have a cube key, which is to the third power. You don't have the 4th root key, the 5th root key, so on and so forth. So anywhere after the squaring key, you have to use this exponent key. The exponent key works the same way, except you're going to get a little caret top in your calculator. There will not be a caret top in mine. So if you're going to do 5 to the third power on your calculator, you're going to press 5, and then you're going to see this caret top, and then you're going to say to the third power, which stands for 5 cubed. Okay? If you look on my calculator, because it's a TI-84 and yours are 83s, if you hit a caret top on mine, it automatically moves it up. It's kind of nice. But it still says the same thing that you have, 5 to the third power. I'm going to hit enter. And 5 times 5 times 5 is 125. Okay? The square root key. The square root key is found as a second function on your squaring key. So to get second function, you hit this light blue button on my TI-84. It's a yellow button on your TI-83s. So, say for instance, I wanted to find the square root of this number. Okay? On your calculator, what's going to happen is when you hit second function, the squaring key, this square root's going to show up, and then it's going to give you a parenthesis with it. Don't worry about that parenthesis, just type in this number, 1,156, and then close your parentheses, and then go ahead and hit enter. On mine, when I hit second function square root key, it doesn't have a parenthesis. I just type in 1156. I press the arrow over to let them know that I'm done. I hit enter, and I get 34 as well. Why is this important that you know how to type these in? With most calculators, you must input fractions on one line. Therefore, you must include grouping symbols to show calculations. Grouping symbols are your parentheses. For example, to evaluate 24 divided by 8 minus 2, you must enter 24 divided by, and 8 minus 2 has to be in parentheses. Why? Because you do that first to get the correct answer of 4, because 8 minus 2 is 6, 24 divided by 6 is 4. If we would have entered 24 divided by 8 minus 2, the calculator would follow the order of operations, doing the division, 24 divided by 8 first, and then getting 3, subtract 2 from it, and would have gave us 1. So notice, just by using your grouping symbols, how you need to get the right answer. You have to put this in first, because what we would do here is we would have to do 8 minus 2 first. Okay? It's very important, especially when you're working with your calculators. Your calculators are only as smart as the person typing it in. Evaluating expressions. Sometimes you'll need to evaluate an expression as part of working with the formula. For example, the formula volume equals L times W times H. All those are together up here. Length times width times height, that's what that stands for, is used to find the volume V of a rectangular solid with length L, width W, and height H, as shown in example 3 below. Example 3 wants us to find the volume of the box shown at the right. So they want us to use this formula, volume equals L times W times H. Well, which one's my L? Well, my L is this long side right here. My W is the width of my box. And my height is this running up and down. So to find volume of that rectangular solid, my length is 3. My width is 2, and I put parentheses around it just so I keep them separate, and I know that they're multiplying. My H is 5. Well, 3 times 2 is 6. And 6 times 5 is 30. Our units are inches. And whenever you do volume, it's in cubic measurements. So this is 30 inches cubed. Volume is cubic measurement. So, say for instance, these were feet, you would say feet cubed if you found volume. Last 3 properties that you need to know. Associative property and multiplication. All this says is for any real numbers, A, B, and C can be whatever you want. If I take A times B and multiply it to C, it's the same thing as taking B times C and multiplying it to A. Multiplication, you can change it up and it'll still be the same. So for instance, if I said 2 times 4, we're going to do that first, times 2, let's say 3, sorry, let's keep these separate, is going to be equal to 2, where we multiply 4 times 3 first. So what that means is no matter what order you multiply these in, 2 times 4 is 8, times 3 is 24. 4 times 3 is 12, times 2 is also 24. So no matter which way you multiply these together, you're going to get out the same thing. Same's true for the associative property of addition. No matter what numbers these are, whatever order you're going to add them, it's going to give you the same thing. So for instance, 1 plus 2 plus 3 is going to be the exact same thing as 1 plus, parentheses, 2 plus 3. Follow your order of operations. 1 plus 2 is 3, plus 3 is 6. Over here on the right side, 2 plus 3 is 5, plus 1 is 6. Okay? Transitive property. This is where a lot of people get messed up, but I'm going to show you an easy example. For any real numbers, A, B, and C, if A equals B, B equals C, then A has to equal C. So for instance, we're going to say A is 8. If that equals 2 plus 6, and 2 plus 6 equals 3 plus 5, then 8 has to equal 3 plus 5. Does that make sense? This is my A. A is 8. My B is the 2 plus 6. Does that equal 8? Yeah. Well, if these two things are the same, 2 plus 6 equals 3 plus 5, then also 8 and 3 plus 5 are the same. Are they? Yes. Those are important properties to know. Thank you very much. We'll see you tomorrow.